Good morning, everyone. Okay, I was expecting exactly that. Before we try that again, let me give you 3 reasons why the next iteration of the Good Morning will have more energy. First of all, we are in the beautiful city of Barcelona, right? I was checking before conference, there is actually the sun out, right? That's part 2. And part 3 is, what led us here is passion, right? Passion about the community and passion about WebAssembly. So with that, let's try one more time. Good morning. That's something we can work with. Okay, great. So now that we have sorted out that, I'm Thorsten, working at Fermion, and
I'm Karthik, Ganeshram, working at Fermion as well.
Okay, and today we talk about composing applications using the WebAssembly Component Model, right? Before diving into that, let's do a quick refresher on the component model just to ensure everybody's on the same page. So the WebAssembly Component Model is an extension to core WebAssembly, allowing us to compose applications from multiple components written in different languages, right? And we express the API or the contracts of those components using WebAssembly interface types or short WIT. So, Karthik, do you have an example of where developers could benefit from using the WebAssembly Component Model to build applications?
Yeah. Let's say I start building a CRUD API using TypeScript because I'm fairly confident writing TypeScript and it's quick and easy to prototype. Then along the way, I decide, one of the APIs I want to be able to compress images that come in before I store them. And I'm like, I want it to be highly performant. So then I'm like, let me write a component in Rust that does it. Then if I could easily use it in TypeScript, it would make my life so much easier by just writing all the API, CRUD API stuff in TypeScript and the compression and compute-intensive code in Rust and just consuming it in TypeScript so that it's efficient and easy to prototype too.
Yeah, that's right. So, while talking to many developers out there, speaking about their requirements, how they build applications, we figured out a pattern that it is smart to have some people taking care about infrastructural components and have multiple teams relying and reusing that in order to be more efficient when it comes to building multiple apps, no matter which languages are chosen or which language is chosen by a particular team. So with that sorted out, let's dive into component composition. And we want to start with basically taking an existing component that provides a sorting functionality. I mean, it does not matter what the component actually does, right? So we have written different sorting algorithms in different programming languages, both or all of them relying on the same WIT word. And we will use latest and greatest tools provided by the Bytecode Alliance and the WebAssembly community to actually do component composition. So we'll use Wasm tools, we'll use WAG, and on top of that, we have to use language-specific tooling depending on which language we choose for our socket component. So with that, Karthik, stage is yours.
So we have a simple demo of just composing components manually. As Thorsten said, we have 2 components here, both providing the sorting functionality. The bubble sort is written in JavaScript, and the merge sort is written in Rust.
Libars, yeah.
And as expressed, the WIT interface for both the components is the same. Here we can see there's one interface called sorting, which exports one function called sort, which basically takes an array and then returns the sorted list back to you. So let's first build the components.
Yeah, so we encapsulated those commands into a make file and have a target called build components that Karthik's going to execute. You want to explain what happens?
So basically, the make file runs the cargo component build on the Rust component to build a Rust create into a WebAssembly component, and we use Jco for the JavaScript component to create a JavaScript component here. So now we have components. How do we use them in our language of choice? I'm going to start a new Rust project where I'm going to consume it. I'm using Rust because it's slightly easier than JavaScript today to compose components in.
Okay. So using cargo component, new, I guess, yes?
Yep. So that creates a new Rust project with a scaffolding for a WASI CLI. And we can see that all it currently has is the main with a hello world print function. So let's say we want to consume.
The other way, yep.
Yeah. Let's consume. If we have to consume one of the sorting components in Rust, the first things we have to do is we have to be able to extract the width interface the component is built for. And then we have to importize. Like, let me quickly go back to the width interface that the components have. Like here, it says the merge sorter exports the sorting interface. But from a consuming component, it has to be an import. So there's a step called importizing it, where exports of one component are translated into the imports so that they can be imported in your other component. So we are going to use Wasm tools for it.
Oh, there. So using basically Wasm tools component width to invert the width file provided by the component developer, right?
Yeah.
And I think you have to create the width folder, otherwise this will fail.
Wow.
But go ahead.
Yeah. Oh.
Yep. No
Oh, that's the
file
wrong
there.
one.
No, you have to. Yeah, and you have to go into live demo to make the path work.
Yeah.
But
I can just, yeah.
it's component, isn't it?
No.
Just press Control. Just follow my instructions. Press Control C, Control L, CD live demo.
Okay.
No, CD
No,
live
nope.
demo. Yep, there we go. So Wasm-tools component. Yep, there we go. Now the path is correct. Okay.
The component is.
Yeah, Control E goes to the end.
No.
Control E. Follow my
Okay.
instructions.
No. Wait.
Do whatever you want.
Yeah.
We're getting there. We're getting there.
We are getting there. Yeah. Merge sorter and.
Yeah. What are you doing?
We are importing.
Yeah. Go. Awesome. I think we made it.
We made it, I think.
Now we have to find the right.
So
There we go.
now we can see the width has been importized, and what was an export there is now an import, so that now we can consume it in the Rust component. So the first thing we want to do is just run cargo component build.
Okay.
That's going to generate the bindings for us, and then.
So now we have the bindings RS.
Yeah. And now, so we just add mod bindings to add it, and then now we should be able to just sort.
So you're way more confident in writing Rust than using the terminal. That's great. Awesome.
Sounds about right.
Oh, that will be so bad for me the upcoming 2 days. All right, so you're creating a random vec with integer values, right, that we want to get sorted?
Yeah.
They are all in
a sorted array.
All right, so you call the sort function.
Yeah, and I need to save it somewhere.
Yep.
Return.
Okay.
And now let's just print it out here.
Yep. Okay, there we go. So now that we have used the component, the next step is obviously building the socket component again.
Yeah. Now we have the component, which imports the interface. But now we have to satisfy the import with a different component, for which we are going to use a different tool called WAC, which basically allows you to compose components together and output a single composed component, where the import is satisfied by the plug component. So plug and socket are terminologies used in WAC, where plug is the component that provides the export, and socket is the component that has the import of the WIT interface.
Before you execute that command, can you do a Control-L so that we end up on top of this? Yeah, great, awesome.
And we have it right here. So,
yep.
So basically what we are doing is we are saying use the bubble sorter as the plug component, and the component we built, the live demo.wasm right now, and output it as a plug.wasm.
So this is basically
connecting it together. It's like fitting two pieces of the puzzle together.
OK. So we end up with plugged.wasm, and right now we use wasm time as a runtime to invoke that one.
And now we can see we get the sorted list.
Awesome. So it's getting better. OK, so we have that other sorting algorithm, the merge sorter. So.
Yeah. So basically, we don't need to do any code changes or rebuild your socket component again. You just use a different plug component, and you run the same WAC.
That will not work.
Why will it not work?
Because you're pointing in the wrong directory again.
I'm in the wrong
You're pulling it from components bubble sorter.
Yeah.
Yeah. I can tell you another tip. Press Control-C.
OK.
Control-L. Control-R.
OK.
WAC. And now choose whatever component you want to from the history. There you go.
And we got a new plug.wasm.
Yep.
And when we run it, we still get the same output. Like, you did not have to build your socket component again.
Yeah. Awesome. So this is using the second sorting algorithm, and you may have guessed from the execution time, this is the plug being implemented in Rust, in contrast to the other one being implemented in JavaScript. All right. This was great. Oh, I am in charge of the clicker.
Yeah. So as we saw, there were many steps involved where you had to like get a component and then importize the WIT, and then you had to WAC components together, and you have language-specific tooling like cargo component for Rust. And if you're consuming it in JavaScript, you use Jco for it. You would have one extra step where you have to manually merge the WIT of your JavaScript component with the imported component together before you can build. So we can see that there are many steps.
Yeah, I mean, the tooling is great. You can think of it like Unix tools that you have to bring in order on your own. You have to incorporate those language-specific tools to have everything in a precise order to end up with a plugged WebAssembly application, and you have to know all the terminal commands, right?
Yep.
But on top of that, we thought, hey, there must be an alternative approach of achieving the same. And that's what we want to look at in the next couple of minutes. So in order to do that, we will use Spin. So Spin is the developer tool for building and running WebAssembly applications. And as Radu already mentioned during the keynote, Spin is right now a CNCF sandbox project. Caleb, that was your point in time where you had to cheer. Yeah, so Spin is obviously addressing all those inner loops, so the day-to-day developer tasks in a language-agnostic manner, providing you like plugins and templates to address all your needs, right? So if you haven't used Spin so far and you want to dive into Spin and learn more, there is the new GitHub organization that we created as part of contributing Spin to the CNCF, and you can find all docs and stuff linked from there. So, but it's more than just Spin, right?
Yep. So Spin also is highly extensible via plugins. So our experimentation here is using a plugin called Deps. It's an experimental plugin that we have been playing around with to see how we can make developer workflows language agnostic and developers to feel at home depending on whatever language ecosystem they are used to. So this plugin can be installed using the Spin plugins install, which is the command that you use to install plugins. And for a deeper dive, there's a repository that can be visited.
OK, so basically, we are right now, as plugin authors, in charge of everything. And the developer, or you in the upcoming demo, you only have to execute one command, right?
Yes.
And we saw while that's really valuable in
Yes.
the earlier demo. Yeah. Okay, correct.
Spin in itself has a component dependencies as a thing inbuilt, which allows plugging in components much easier by just expressing it in a manifest. And Spin Deps plugin helps you automate all those tasks without you having to manually modify a TOML file and things. You just say, I need this component, do whatever needs to be done, give me bindings, and let me go about writing my code as it is, without having to know much about WIT or things of that sort.
All right, so let's explore the Spin and Spin Deps way of doing component composition. You have to go one folder up.
Yep.
OK.
So Spin has this concept of templates, which allow you to easily scaffold your new applications.
Yeah.
So here I've scaffolded an application in TypeScript. And so basically, it asks me a few questions to set up the project for me. And then it just set up the project. So
one more question before you continue with that. Can you cancel that? Control L again?
Yep.
And do a spin new, just to give people an understanding of what templates we provide. So obviously, we created a bunch of templates. You can roll your own templates. So we decided to roll with TypeScript right now because we already looked at Rust in the first demo, right? OK, go on.
Yeah.
So you want to go to live demo as well? Yeah. Yeah, there you go. Can you bump the font size a bit? There we go. Thanks.
So we can just see that we have the package.json and our source, which is basically just a regular TypeScript app, which has a router and two routes called / where it just returns hello universe, and a greet, or a hello /name, where it returns the name of the path parameter passed.
So that's the file new experience. You end up with a working HTTP API. OK.
Yeah. So the interesting part here is the Spin manifest, or the spin.toml, which is what describes the Spin application. So it basically defines what capabilities an application has and how it should be assembled together. Like we can see that there is one trigger called the HTTP trigger, because we are building a HTTP app here, and it has the component live demo 2. And if you go look further into the configuration of the live demo 2 component, we can see that we have a build command, so we can just do a spin build, and it will automatically take care of building the component for us. So let's just run the build for it first.
Yeah, it's a smart idea to execute that right now, because we have to pull down a couple of NPM packages. You have to go into live demo 2. There we go. Yep. So that's right now pulling all the dependencies, right? And once that's done, it's basically turning source code into WebAssembly.
Yep.
Awesome.
So it's using internally a couple of bytecode alliance projects again. The Starling Monkey and componentized.js projects are used here to allow running JavaScript in WebAssembly.
OK. So depending on the conference Wi-Fi, this could take
a while.
A while. Awesome. What about maybe move to VS Code back for a second. Oops, sorry. And go into index.ts and maybe already start adding a new route that we want to invoke, right? So we can save some time over there. I think that should be a string. Yep. All right, so we are adding a new get endpoint at sorted. That should, right now you can create a random array of integers, maybe a little more random than the last one.
Is this random enough?
Yeah. Awesome. OK, maybe stop here, double check if we have installed like all the necessary packages. Maybe not.
Oh, it does, because we already have type support here.
OK.
Or maybe not. I lied.
Then let's cut here.
It's still happening.
Still installing. Oh.
It's taking a while.
OK, maybe you may continue with creating the response. Sorry.
Oh, it's done.
It's done. Maybe not. And there are things that we can't script, like the Wi-Fi, right? OK, Control L.
Yep. And now to run the application, you can just do a spin up, which basically starts the application for you. And we can then curl to see that the application is working. So we see the hello universe on the default route.
Okay.
And if we do a hello Wasm.io, we see hello Wasm.io again.
Okay, so this is the regular Spin workflow, the developer experience that we provide with core Spin CLI. And now let's bring in the Spin Deps plugin.
Yeah,
so
Spin
we have installed the Spin Deps plugin already on that machine. And that gives you basically just a single command from that point of view. But
yeah, so basically what we are doing is we are doing Spin Deps and pointing at the component we have. For instance, here it's a local component. It could also be a registry component. So once you do that, it's going to ask you for a few things about what you want from the component. You just do that, and it generates a new NPM package for you within your project.
Oh, so you rushed through that wizard. Can you go back and explain what basically happened or what it asked us?
Or I can just do it again.
Yeah.
So basically, it's asking for packages to import. Like there was only one package in the component that we are adding to it. So we add the Wasm.io demo.
Yeah.
And then we choose what interfaces we want to be able to use in the socket component here. So which is sorting. And the third question is, which component do we add? Like a Spin manifest can define multiple Spin components. So we choose, since we have only one, there's only one option here. But if you have multiple, it lets you choose between them.
OK, so this added something to our source project, right?
Yep. Like if we go all the way back here, we see a new folder called Spin Deps. And it has generated a new NPM package for us that we can consume. So basically, it embeds the width for us, which is already importized. And then it also has type support so that we can directly use it.
But I think you have to do an NPM install.
Yeah, I have not done the NPM install yet.
Maybe Control-Ln again? I'm a fan of looking at top of the screen.
Yeah. So I did install it now. And so once it's installed, we can go back to our program here. OK.
So we were halfway through implementing that endpoint. Maybe you can scroll a little bit to have that text also on top of the screen. OK, awesome. OK, so right now we would assume, there we go, VS Code providing us IntelliSense in order to use that component, no matter if it is written in Rust or whatever, right?
Yeah.
Because the Spin Deps plugin.
Spin Deps has generated the types for us.
OK. So now let's finish that one by turning the output into a proper HTTP response. Maybe status 200, I assume. Even setting the header to content type. Yep. Almost. There we go. All right, so this should right now give us an HTTP 200.
Yeah. So now let's build it again. Spin build.
Yep.
And now we see that it's componentizing.
OK.
Now we have the component, so we can go spin up, which starts the component. And since we have the path set up as, I forget if it was sorting.
I think sorted, yeah.
There we go. We have the things in sorted order.
Yeah, we have it in pretty order. OK. Move to the slides, please. Awesome. Do you want to explain what happens under the covers?
Yeah. So quick under the hood description here. So when you do a Spin Deps add, it first tries to find if it's a local component or a component from the registry, and then fetches the component from the registry if it's the registry, or reads the local file system. Then it extracts the width for you and importizes the width. And then it tries to identify the language the Spin component, source component is in, which uses some heuristics like, is there a package.json or a cargo.toml? Or you can also override what language it is generating bindings for. And then depending on the language, we generate bindings. And if it's JavaScript, we wrap it in an NPM package so that for the developer, it seems smooth and they are within the NPM ecosystem. If it's Rust, we just have the importized width and then just use width bindgen and put the generated code inside a source deps folder from where they can do mod bindings or mod deps and then start using it.
Awesome. So let's go off script and let's stress the demo gods a little bit. He doesn't know about that. Can you go back to the terminal, stressing your terminal?
Yeah.
capabilities.
Yeah.
Okay. So we installed that from the local path. Can you install it from the registry, or what happens when we install it from the registry? So instead of pulling it from the local machine, right, at some point we graduate, right? Our component, at some point, bubble sort is implemented, right?
Yeah.
So we publish that to a registry. In our case, that's GHCR, or is it something? No, it's something fronted.
Yeah, it's backed by GHCR.
Okay, backed by GHCR, and then we pull that component from there,
And
right?
it's the same wizard again. So when we do this, the one difference that we can notice is if we go back to the Spin app and look at the spin.toml and go all the way to the bottom, we see that we have added a dependency which uses the registry instead of the local file system.
Okay, so it recognized, oh, I know that package with that world, and discovered that it was there, so it replaced the dependency expression there on the fly instead of adding a secondary one.
Yeah.
Which means you should be able to do a spin up -b or build, sorry.
Yeah, we don't actually have to build here because spin takes care of the composition. So you just do spin up, and it should just work.
Famous last words. Okay, try. Oh, it does? Great.
And it still works.
Awesome, awesome. Okay, sorry for going off script. Great. So, but let's do some real talk. Obviously, as Karthik mentioned, this is an experimental plugin, and as of today, we are supporting like 2 languages for socket components in WAC terminology. So that's Rust, TypeScript, and JavaScript. Treated them as a single language, right? For plug languages, or for the languages for creating plug components, we support everything that is able to turn code into a Wasm component. But keep in mind, it's still experimental. But Karthik, what's on the roadmap?
The roadmap is to add support for more socket languages like Python, for one, and then like graduating out of experimental status by making it more production ready for it to be used, and eventually start writing a SIP, which is called Spin Improvement Proposal, to make it part of mainline Spin instead of it being a plugin, being an experience that you have as a part of the Spin experience.
Yeah, so basically feeding it back into mainline Spin so that all Spin developers, users could participate from that smooth, elegant way of bringing all those tools into the right order, right?
Yeah.
All right, so before wrapping up this thing, let me quickly do a recap of what we discovered. So we saw Karthik battling my terminal, and it was maybe that was the reason, right? Because it was my terminal. No, so we started obviously with a quick refresher to get everybody on the page on the WebAssembly Component Model. We did like manual component composition using those great tools provided by a lot of folks sitting in this room, right? However, we want to lower the barrier for like application developers to adopt WebAssembly components and to compose applications. So that's why we started building an experimental plugin that we called Spin Deps, which is open source.
It is.
Right? It is on GitHub, and you can install it on top of your Spin CLI to play around with it. With that, so there's code. It is on GitHub as well. Thanks for your attention, and if you have any further questions or you want to chat about composing applications, then join us at the Fermion booth. They have no questions. They want to go outside and check if the sun is really there. There's a question.
I have a question. It's working. So what is the timeline? So it's eventually ending up in Spin mainline, but what does that mean? Like, it could be years? I don't know.
The hope is not years, in a few months.
Few months.
Yeah, like because we have to write a proposal and it has to go through community review, and like we have to design it a bit more. Because it's experimental, I've taken some shortcuts. So those need to be ironed out a little more. So I would say in the near term-ish, that's the hope.
More questions? If not, find us at the booth.
Yeah.
And with that, thanks you once again.
Thank you.
Bye.